Hello, I'm Achut Nair from Nair's Aviation Ground School. This is the 20th video in a new series of educational aviation videos for the aspiring pilot. The aircraft was in the air and roaming the skies since the start of the 20th century. As the aircraft improved and longer flights became a possibility, the need to know where the airplane was and where it needed to go became pressing. Air navigation started to take off. This video is about air navigation. Navigating an aircraft has much in common in navigating in a car. Proper planning, resource management, and observational skills are required to successfully navigate in a car or in an airplane. The differences arise between aerial and surface navigation when considering the risks and requirement needed in operating an aircraft. Successful air navigation involves piloting an aircraft from place to place without getting lost, not breaking the laws applying to the aircraft, or endangering the safety of those on board or on the ground. Air navigation differs from the navigation of surface cars in several ways. Aircraft travel at relatively high speeds, leaving less time to calculate their position and route. Aircraft normally cannot stop in midair to ascertain their position at leisure. Aircraft are safety limited by the amount of fuel they can carry. A car can usually get lost, run out of fuel, and then simply wait to be rescued. There is no in-flight rescue for most aircraft. Additionally, collisions with obstructions are usually fatal. Therefore, constant awareness of the position is critical for aircraft pilots. The techniques used for navigation in the air will depend on whether the aircraft is flying under visual flight rules, VFR, or instrument flight rules, IFR. In the case of IFR flight, the pilot will navigate exclusively using the instruments and radio navigation aids such as beacons or as directed under radar controlled by air traffic control. In the VFR case, a pilot will largely navigate using deduced reckoning combined with visual observations known as pilotage, with reference to appropriate maps. This may be supplemented using radio navigation aids or satellite-based positioning systems such as GPS. The first step in navigation is deciding where one wishes to go. A private pilot planning a flight under VFR will usually use an aeronautical chart of the area which is published specifically for the use of the pilots. This map will depict controlled airspace, radio navigation aids, and airfields prominently, as well as hazards to flying such as mountains, tall radio masts, etc. It also includes sufficient ground detail, towns, roads, wooded areas to aid visual navigation. Instrument flight rules navigation is similar to visual flight rules flight planning, except that the task is generally made simpler by the use of special charts that show IFR routes from beacon to beacon with the lowest safe altitude, bearings, and distance mark for each route. IFR navigation also requires pilots to consider the flight minimums at the departure and destination airports and requires more in-depth planning in case of emergencies. In recent videos, the flight instruments found in an aircraft were discussed. In addition to the pitot static instruments, the magnetic compass, and the gyroscopic instruments, most aircraft also contain navigational instruments. These instruments rely on radio navigational aids to provide navigation information to the pilot. Newer aircraft also include GPS navigation instruments. The common radio navigation instruments found in the aircraft include the ADF indicator and the VOR indicator instruments. A non-directional radio beacon, or NDB, is a radio transmitter at a known location used as a navigation aid for aviation. As the name implies, the signal transmitted does not include inherent directional information. NDB signals follow the curvature of the Earth, so they can be received at much greater distances at lower altitudes, a major advantage over the VOR. However, NDB signals are also affected by atmospheric conditions mountainous terrain, coastal refraction, and electrical storms, particularly at the long range. The automatic direction finder or ADF indicator instrument can be a fixed card, movable card, or radio magnetic indicator or RMI. An RMI is remotely coupled to a gyro compass so that it automatically rotates the azimuth card to represent aircraft heading. While a simple ADF displays might have only one needle, a typical RMI has two, coupled to different ADF receivers, allowing for position fixing using one instrument. Very high frequency omnidirectional range, or VOR, is a type of short range radio navigation system for the aircraft, enabling aircraft with a receiving unit to determine their position and stay on course by receiving radio signals transmitted by a network of fixed ground radio beacons. It uses frequencies in very high frequency band from 108 to 117.95 megahertz. VOR stations are fairly short range. The signals are line of sight between transmitter and receiver and are useful for up to 200 miles. Each station broadcasts a VHF or very high frequency radio composite signal, including the navigational signal, the station's identifier, and voice, if so equipped. The navigation signal allows the airborne receiving equipment to determine a bearing from the station to the aircraft, direction from the VOR station in relation to the magnetic north. The VOR instrument includes a course deviation indicator or CDI, omnibearing selector or OBS, a to/from indicator, and flags. The CDI shows an aircraft's lateral position in relation to a selected radial track. It is used for orientation, tracking to or from a station, and course interception. On the instrument, the vertical needle indicates the lateral position of the selected track. A horizontal needle allows the pilot to follow a glide slope when the instrument is used with an instrument landing system. The NDB and the VOR have been around for decades. With the proliferation of the Global Positioning Satellite System in the 1980s, GPS navigation has begun to spread in the aviation community. Instead of using radio navigation aids, the GPS receiver in the aircraft uses the satellite signals to calculate the aircraft's current position, the flight route, and the destination. GPS is a much more accurate and easier to use navigational instrument than the VOR or NDB, and most of the newer aircraft operating today include GPS navigation systems. Garmin is one of the most popular GPS receiver manufacturers. The GPS is the future of aerial navigation. Navigation is a very important aspect of flight. After learning how to fly the aircraft, knowing where you are and where to fly the aircraft is the most important aspect of flying. Navigation takes up most of the pilot's workload, so it is important that aspiring pilots need to be very aware of the navigational system in the aircraft. The ADF, VOR, and now GPS instruments are used in the cockpit for aerial navigation. For more information, please contact us at liftanddrag@gmail.com and visit our website at nyersaviation.webnode.com. Thank you. Safe flying.